Okay, boys and girls, I'm Dr. Lo. So let us start. Although others still not yet join us, but it's okay lah. Okay, dear, at here last week our lesson we stopped at lesson number 3. Actually, it's like last part of chapter 1 now. We almost finished chapter 1. Okay, we learned about finding resultant force. Okay, then after that, we're learning how we resolve the force. Resultant force is from many force. Then we find the single force. Okay, so resolutions of forces is different. From one single force, we split into two components of the force, horizontal component and vertical component. Okay, so today, this small part, page number 13, page number 13, we will use the knowledge about the resolution of forces. Okay, then we solve this kind of problems. So condition for equilibrium, that means that the force is balanced. Force is balance force. Okay, balance force. When balance force, what in our brain? Okay, the net force is zero. Net force is zero. So when net force is zero, we can say that the upward force must be equal to your downward force. Okay, the force on your left hand side must be equal to your. So for the vector at here, there is three force. These three force will be balanced each other's. Why? We have a look. We already learned about this. Okay, this one is 90 degree. 3 Newton and 4 Newton. We know that if only these two force, without thinking about the 5 Newton, we only think about 3 Newton and 4 Newton. These two force, it will producing a resultant force in this direction as we using the Pythagoras theorem. Okay, we know that this resultant force should be 5 Newton. Okay, because 3 Newton here, 4 Newton here. Okay, you using a mathematic way, you will find out that resultant force is actually 5 Newton, right? Okay, right now, if you don't have the 5 Newton F3, supposedly the object will be moving in this direction with 5 Newton. Okay, so right now, if you balance it, that means that you will have a third force to balance, cancel out this 5 Newton in the opposite direction. That's why 3 Newton and 4 Newton, F1 and F2, when there is a F3 in opposite direction with the resultant force, this one, these three forces, it will become balanced. Okay, these three forces will become balanced. If we draw the vector diagram, actually they will form a closed path. Okay, they will form a closed path. This part, actually in future, we learn about the force. We will comes with more question about this closed path lah. Okay, but right now today, mainly what we want to talk is actually using some mathematic way resolution of forces to settle our problem, to solve our problem. Okay, so this one, closed path, the angle, the arrow here, they will be follow one by one. Okay, this is closed path because they balance each other's equilibrium, each other's. Okay, so but this one we will repeat in future. Okay, so here we comes to the past year question. Here, a pendulum bob is held stationary by a horizontal force. Okay, boys and girls, we highlight this. This is a keyword, stationary. When stationary means that it's not moving. Okay, not moving, what does it mean? Meaning that force is balanced. Okay, balance force. So when balance force, what does it mean? Equilibrium. Okay, equilibrium. So these three forces, they must balance each others. Okay, they must balance this. If we draw the, the vector diagram, it might be like something like this. Okay, but we didn't draw in scale. Okay. So this one is a hash, this one is W. Can you see that they form a closed path? Okay, the vector is closed path, but this one we don't know the magnitude lah. Okay, we just sketch it. Okay, dear, we solve the problem by using the resolution of forces. So how this one T, we need to resolve it into Y and into X component here, vertical and horizontal. Okay, so that means that I using my red color, I will resolve it into going up here, TY, I label TY. Then I will resolve from the T into TX. Okay, So this one your mathematics, so you look at this like this one mathematics Z. Okay, so this angle should be 30 degrees. So we label this one should be 30 degree. Okay, now when you want to solve this problem, you can ignore this one already, the t, because we already resolved the t into y and x axis. Okay, so because it's stationary, meaning that it is balanced, upward force should be equals to your downward force. So at here, your ty should be equals to your w. Okay, so at here, ty should be equals to your w. Okay, then tx should be equals to your h. Okay, the horizontal component in opposite direction, tx should be equals to your h. Okay, do you know that how you find ty? How you resolve ty into t into ty? Okay, then can you please try which answer will be the correct answer? Okay, Junxiong and Jiaxuan, you try and then you type your answer in the chat box. You type to Newton Scholar because Dr. Low is my iPad. Okay, so you think how you resolve it. This one actually is related with what we learned in last week, this one. Okay, so this one is f resolve into fx. So it will be f cos delta, then we get fx. Okay. Then this one, y component without any angle here, it will be f sine theta equals to fy. So you apply this knowledge, comes to here. Can you tell me which statement is correct? Junxiong and Jiaxuan, try and then tell me your answer. If you graduate from O-level IGCSE, actually resolution of forces is new thing for you. But if you graduate from the government SPM, this one we learn in Form 5. Like, any answer? Or any question you want to ask? If you didn't respond to me, I don't know that whether you get it or not. So how, dear? Jiaxuan. Okay, Jiaxuan is like this, resolution of forces, this one, dear. You look at this, now you assume you learn, okay? This one, F. We want to resolve into Fx, okay? So this is the angle. Okay, this is the angle. So you can using the mathematic, okay, trigonometry using cos. Cos theta. Cos theta at here, because cos is tua ta ka c a h. Okay, adjacent. So fx divided by h. H is f here. Okay, so we rearrange. We found out that how we find fx is using f cos theta. F cos theta. Okay, so with that angle at here, no angle at here, we're using f sine theta. Actually, it's your mathematics. Okay, so we look at this here. Ty with the angle between them. Okay, between the t goes to resolve to ty. So we should using t cos 30 degree is equals to weight. Okay, then you look at the tx at here, there is no angle at here. Okay, so if you refer back to the video, the patch at here. Okay, so without the angle at here, this one should be f sine theta. So at here it comes to this. So this one should be t sine 30 degree equals to the h. Okay, so at here your answer Let me have a look. Junxiong, did you get the answer? No, dear. Answer should be C. Okay, so if you're using mathematics like this, so this one is your y, then this is your here, this is ty, this is t. Okay, so at here, this is the angle 30 degree. Your tua ka so, okay, tua ka is cos, then 30 degree, okay, equals to your adjacent, which is your ty, divided by your patch, hypotenuse, so it's t. So your ty actually is t cos 30 degree. Okay, for this part, Junxiong and Jiaxuan, did you get it? This is your mathematics, trigonometry. This one, is it okay? Did you able to get this point? There is a reaction button there. If you get my point, then you react to me, then I know that you get this point. Okay, Junxiong, okay? Jiaxuan, do you okay with this part? Okay, yes. So from here, ty should be equals to your w. That's why t cos 30 degree is equals to w. Okay, then if you want to talk about tx, teacher, how about tx? Actually, also mathematic like this. This is your t. So this is your ty, tx. So this is your t. So this one without the angle is here, 30 degree. Okay, the angle is here. So how are we going to solve? We can using the sine. So SOH so. So sine 30 degree equals to opposite. This is opposite. Opposite should be tx divided by h is hypotenuse, which is your t. So at here tx it should be t sine 30 degree. Okay, t sine 30 degree. So this one is your horizontal component equals to your h at here. So do you get about this point? This is another your mathematic trigonometry. Do you able to get this? Yes or no, dear? Okay, so for this one, uh, in general way, if there is angle in between t and your resolved vertical component part, okay, so you're using cos. T cos 30 degree is ty. Here without any angle, and then but then these two is formed at 90 degree lah, okay? So it will become t sine 30 degree. T sine 30 degree, you get tx. Okay, this is about resolution of forces. Okay, we goes to question number 2, and then we try dear. Here, you look at this. Okay, there is they're holding, okay, holding a load. So there is a force at here. That means that this one is it a force? Yes, okay. Has an arm which is attached to the pulley. Then a cable. Okay, here, how we solve this kind of question? Because it's holding the load, support a load. So that means that this force, it must resolve to this direction. Okay. Then these two forces, let's say Tx or Tx2, then it must be balanced by this force. Okay, it must be balanced. Support, that means that it's not moving already. This object is holding and not moving. So at here, what should you do is 10 kilonewton should be resolved to this direction. And then another 10 kilonewton should be resolved at here. And then these two is the same directions. So it should be equals to your force. So do you able to using resolution of forces to find out what is your force F here? Okay, so I draw like this. So this 10 kilo, we should resolve it into here. So this one I can label Tx1. Okay, so this one 10 Newton. So there is another 10 kilonewton, Tx2. Okay, these two must be equals to these two like this. It should be equals to the F in the opposite direction. Okay, so that they can be achieved equilibrium. Okay, so Tx1 is 10 kilowatt 30 degree. Sine or cos? Sine or cos? Okay, Tx2 10 kilowatt, 30 degree. Sine or cos? What do you think? Jiashen and Junxiong, what do you think? We should using cos or sine? If the angle between them, cos, correct. So using cos at here, cos at here. Okay, because this one, you see, this one, going out. So this one, our resultant also going out. Our resolve, the force that we resolve also going out. So we found out that these two forces actually they are in the same direction. These two in the same direction. So we should edit them together. So T1x should be added with Tx2. Okay. So this one force is equals to Tx1 plus Tx2. So can you count for me? What is the force that we should have in order to able to support the load? So press your calculator and then tell me what is the answer. Correct. Jiashen, correct. It should be donkey. Junxiong, do you able to get it? You must resolve the forces into one direction, so we only can balance and cancel out. Junxiong, okay, huh? Okay, dear, here. Same thing. Okay, here is, this time I guide you a bit, okay? This is the weight going down. This is the weight W. So the question said that equilibrium, the system is in equilibrium. Then hanging with the angle to the horizontal, the tension is 150 Newton. Assume that the rope and the hook has negligible weight. Okay, they're asking you what is your weight. How we know the weight? You should know the force in the opposite direction, because it must have a force in this direction to balance our weight. Okay, where is this force? Actually, these two force, vertical force, is come from the tension here. So I need to resolve it into this direction. Resolve it into this direction. 10K cos 30 degree. It means that at here, this one, 10K, the tension T. T at here is 10 kilonewton. We resolve it into here. We resolve it into here. So 10K, because in between here, there is angle, so we're using cos 30 degree. 10K cos 30 degree, we will get this. Then another side, this one also 10K. 10K cos 30 degree, we get this Tx2. Right, Josh? Is it okay? But not car, so is AH. Car, so, tua car, so. Okay, so, like just now at here, dear. Okay, this one T at here actually is your hypotenuse H. Okay, Ty is your adjacent here, adjacent. So car is adjacent divided by your hypotenuse. So your resolve, the result that you resolve should be the tension cos the angle. So we come back to here. The tension cos the angle. This is what you resolve out. The tension T cos 30 degree. You get your Tx. So you can refer back to here. How we get the T that we resolve is actually T cos 30 degree. T, the one that the force that we are going to resolve actually is hypotenuse. It's the longer line. So you just need to remember, now with the force, we resolve it into X or Y component. If the angle between them, we're using cos. If there's no angle between them, we're using sine. So this one is the same. The angle between the resolution of forces, then this one is our tension. So there is angle between them, we're using cos. 10 cos 30 degree. So I will get this Tx1. Yashin, is it okay? Cos 30 degree is equals to 10k hypo. No, this is hypotenuse. This one is longer line. We resolve from here to two components. That means that this one must be the largest or longer line. 10k is your longer line. It's a hypotenuse. Then you will resolve into two shorter and smaller force. You get it? Okay. So the one original force will be the longer force. Okay, the original force will be the longer force. Okay, so you look at here. For this question, you want to find the weight. So you need to find the upward force. So you need to resolve the 150 and 150, resolve them into vertical force. Okay, so at here, okay, so if you are using this, you see your mathematics, Z. Here's Z. Here is 17 degree. That means that this part also 17 degree. Okay, on your right hand side, this one also the angle at here is 17 degree. Okay, you need to resolve your 150 Newton, the tension one. Okay, I label this one is tension Y1. Okay, then they will have another vertical force. I label it as TY2. Okay, so the left hand side and right hand side, the force, the tension due to the force due to the rope, okay, they will resolve in. So can you trying to find how, how you get TY1 and TY2? And then these two add up. Junseong and Jiaxuan try. So how you are going to count your TY1? Correct, Junseong, correct. So what is your final answer? Equilibrium. So that means that force is imbalance. Your upward force should be equals to your downward force. Okay, your upward force will be Ty1 plus Ty2. We resolve the two forces going up. Okay, then the force downward is your weight. Okay, Ty1 should be 150 Newton. Okay, angle not between them, so we're using sine 17 plus 150 sine 17 equals to your weight. If you press your calculator correctly, you should able to get the answer. We got 288 there. 150 times sine 17. Okay, times 2. I get 88. 88 Newton, or I can write 87.7 Newton. Junseong, your working step is correct, but your answer is not correct. Is it your calculator in others mode? Oh, yes. Okay, Jiaxuan, is it okay? If we want to find the Tx1 at here, Tx1, then it will be 150 cos 17. Okay, if we want to find Tx2, it should be 150 cos 17. So can you see that left and right, they also balance. Up and down should be balanced so that the equilibrium. Okay? Okay, in our AS, final answer, we have to give to 2 to 3 significant figure. 2 to 3 significant figure. We are not talking about decimal place. Talking about significant figures. So your answer is 88 and 87.7 Newton. These two answers can be accepted. Okay, so this one is actually practice about the resolution of forces. Okay, resolution of forces. Last week we did learning about resolution of forces. So what else? Let me have a look. You see, last week we resolved this force into two. Okay, we resolve this force acting Newton into two. So at the end, at here, this is the vertical. Then we got two horizontal. Then we added up them together. Okay, so this one, it's okay. Jackson, you watch the video recording. Then after that, you recall again. Okay, so there we goes to the lesson number 5. Okay, lesson number 4 is actually for you to self-practice. After you finish practice, I will show you the working step. Okay, so I will share in the group my working step. Okay, that one is for you to self-practice. Okay, then actually we finish our chapter 1. We goes to chapter 2. Okay, if I'm too fast, please let me know, or anything you haven't finished writing it down. Then if we already we already goes to next page, you have to let me know. Okay, can we proceed to the lesson number 5? Two of you okay? Is it okay? Reaction button, press it. Then I know. If not okay, then let me know what is your problem. Okay, okay? Okay, goes to your chapter 2 is about the kinematics. Okay, kinematics is learn about the motion, but we didn't learn about why the motion like this. Okay, why the motion like this, that is in chapter 3 about dynamic. That one will be talking about the force, something like that, the mass. Okay, for this one we only learn about the motion. Okay, here distance and displacement, what is the difference? In year 10, we already learned, okay? Distance is the total path. I don't care how you move, you just tell me your total path. Okay, so for example, this total path that I move is 10 kilometer. Okay, I'm walking from here, go. Okay, I just count your total path that you travel. So for distance, it is scalar quantity because only got magnitude. I don't care about your direction. You just told me your magnitude, how long the path that you travel. Okay, displacement is different. Displacement need to consider direction. I will ask you, hey, where is your starting point? So here is my starting point. Where is your ending point? Here is your ending point. Okay, from starting to ending, we find a shortcut path. That is our displacement. Okay, starting, ending, we draw a straight line. That is your displacement. So do we need to have a specific direction? Yes. We need to know your directions of starting and ending. Okay, so this one is called displacement. So displacement, we say that it is a vector quantity because it have the magnitude and direction. Okay, here, write it down, direction. Okay, from here, we only can know to calculate the speed and velocity. Because speed is we're using the distance divided by time. Velocity is we're using displacement divided by time. Okay, so can you see that distance is scalar, time is scalar, no direction. So of course your speed is also in scalar quantity. Okay, normally how we define what is your speed? How you define your speed? Okay, can you see that in mathematics? You must know about this called rate, R-A-T-E. Rate meaning what? Per unit time. Okay, this is meaning per unit time. Okay, per unit time. So distance per unit time. Displacement per unit time. Okay, so we will say rate of change of displacement. So that is velocity. Okay, then here acceleration. So we know that acceleration is the change of velocity divided by time. Am I right? This part is actually change of velocity. This one, v minus u is actually change of velocity. How you define acceleration? A rate of change of velocity. Okay, so acceleration involved with velocity, which is a vector quantity. Of course, acceleration also a vector quantity. Okay, so this is all the basic idea that we already know. But how we apply this knowledge in our year 12? Okay, so we turn to your page number 2. Okay, here. This one is the past year question 2023 and also in the 2016. Okay. So at here, about travel from X point to Y point, okay, around a semicircular track of radius 1.0 meter. Can you tell me what is the displacement of the ball from X to Y? Then try. Okay, B is correct. Okay, B is correct. Why B is correct? Displacement is starting here, ending here. So you draw a straight line. This will be your displacement. Okay, this will be your displacement. Then how you know it's 2.0? Because from here to here, center, this is your radius. So it's 1.0 meter. Then from here to here is another radius. So which is 1.0 meter. This one is something like a diameter, you know. From here to here is actually your diameter of your circle. Like this. Okay. So at here, your answer should be 2.0 meter. But not A is because displacement got direction. So it's pointing from here, the north part pointing to the south part. Okay, this is the direction of your displacement. So it's due south. Okay, Jiashen, is it okay for this question number 1? Okay, there we comes to here. Aircraft fly from London to the Sydney in the time of 21 hours 40 minutes. The distance travel is 17,000 kilometer. What is the average speed? Okay, dear, average speed, speed at here, speed is actually the distance divided by time. Okay, I don't care how you move. Just tell me your total path. So your distance at here is 17,000 kilometer. So you have to convert it into meter divided by the time. You see all the answer at here is per second. So you have to convert this into second. And then you match here A, B, C, D. Which one is your correct answer? For this one, actually, they want to test you. Do you know how to do conversion of and using the prefix? Still remember prefix? Okay, this one is the prefix. So prefix tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. This one in our lesson number 1 we already learned. And then your calculator also can help you. Let me think. Calculator, you press 1. Okay, then you press OPTN, option, LPTN, yeah. On your left hand side, then you press, if not mistaken, is number 3, engineer symbol. Okay, then you choose what is the prefix on showing on your calculator, then you press the number, then at the end you press equals. Actually inside, they will show you the prefix. Okay, you press 1, calculator, press OPTN, options, choose number 3, engineer symbol, then you should be able to see the prefix. Okay, tera is 10 power of 12, 9, 6, 3, -1, -2, -3, -6, -9, and -12. Okay, can you try solve this question and then tell me what is the correct answer? Try and then tell me your answer. Jiaxuan, yes, correct. How about Junxiong? Junxiong, do you able to get the answer? 17,000 kilo. Kilo is times 10 power of 3. Okay. Then the time at here, 21 hours with times with 1 hour is 60 minutes. Okay. Then at the end, we got another 40 minutes. So this one is the minute times 60 seconds. So if you press your calculator, everything correct, here it should be 218 meter per second, or we say two significant figure 220 ms negative 1. So your answer should be C. Your answer should be C. Zhisheng, okay? So for this one, they are testing on you. Do you know that how to do conversion? And then don't forget about the prefix. Okay, so at here we test another question. A car travel anti-clockwise along a horizontal circular road of radius 12 meter. The car takes a time of 4 seconds. Okay, so this is the time. Okay, to travel from P to Q. Okay, so they travel from here goes to here. Okay, what is the magnitude of average velocity? Okay, dear. Velocity is the displacement divided by time. Okay, where to where is your displacement? Can you try? Can you try? Displacement divided by time. Zhesheng, yes. Xiaosheng, do you have idea? Starting, ending, draw a straight line. That is your displacement. Then you have to find out what is the distance. Start from P point. So this is my starting. End at Q point. So I find the shortest path. So this one should be my displacement. Displacement. Okay. The rest of the equation actually is your mathematics. Okay, here 12 meter. This one also 12 meter because this is radius one. Right? Then displacement is how many? Displacement, you're using your Pythagoras theorem, which is the square root. Okay, 12 square plus 12 square. So that is your displacement divided by 4 seconds. So your answer should be 4.2 meter per second. Okay, so this one is actually your mathematics like this, dear. Like this. Okay, this one is A, B, C. How you get your C? Mathematics. C square is equals to A square plus B square. So C is actually square root A square plus B square. Okay, so this part displacement, actually you're using a mathematic Pythagoras theorem to solve it. So Jiaxuan, is it okay for this question? Answer should be A. Okay, like boys and girls, we go to your next page. Next page is about graph. Graph. Okay, we go to our next page. So displacement time graph. Displacement time graph at here, if we finding the gradient, okay, for example, this one, second question at here, this one, second graph. If we finding the gradient, maybe I draw at here. Okay, this one is the displacement. This is the time. Okay, the graph is like this. If we're finding the gradient should be your y-axis divided by your x-axis, right? Y2 minus y1 divided by x2 minus x1. Okay, what is your y? Y is your s, distance. Y-axis is for your distance. What is your x-axis? Is your time. Okay, displacement, not distance, displacement divided by time. What the physical quantity we get? Like, answer me. When I'm finding the gradient, actually I'm using displacement divided by time. So actually what I'm calculating, you are calculating velocity. Yes, thank you. Velocity. So what I can say is gradient is actually counting velocity. So gradient of the displacement time graph is velocity. Okay, write down velocity. So at here, gradient is equals to the velocity. Can you look at the first graph? Is there any gradient? Gradient is zero, gradient is constant, gradient is increasing or decreasing. So when you are like this, what happened to your gradient? Your gradient should be, tell me. Zero. Zunxiong says zero. Jiaxuan, yes, zero. Zero gradient. So this one zero gradient, what does it mean? Zero velocity, am I right? Zero velocity means what? Object at rest. Or we say not moving. Okay? So from second, 1 second, 2 second, 3 second, 4 second, object still staying at 10 meter there, not moving at all. So at here, velocity is zero. Okay? So we look at the second graph at here, 1 second, 2 second, 3 second. Okay, the distance from zero become 1, 2, 3. Okay, something like this. Okay, here, gradient from the graph. The gradient at here, if you're finding your gradient, you draw a triangle. So you will find out that no matter at where you put your triangle, you slightly move and change the position, move up or down a bit, you will find that the gradient that you get will be a constant value, constant gradient. Am I right? The gradient is constant. So that means that your velocity is constant. So for this, how they move? Constant velocity. Okay, constant velocity. Okay, for this one, is it okay? Is that clear? Okay, Junxiong, okay, Jiaxuan, okay, yes, dear. Here, look at the curve. This one is the part that we have to think, okay? So how we solve this kind of question? I'll encourage we can draw a triangle like this, and then draw a triangle like this, okay? Like this, okay? Then after that, you ask yourself, this one, I can just draw a line to show my triangle like this and like this. Okay, from time to time until the end of the part at here, this part, the line is steeper or less steep. If steeper, this one, of course, is steeper lah. Can you see? This is steeper. If steeper meaning that the gradient is increased or actually the gradient is decreased. From here, you will find that the gradient it doesn't constant anymore because it's not a straight line. It doesn't constant. So you calculate the gradient at here and calculate the gradient at here is totally different. Okay, so this one is steeper line, steeper gradient. So the gradient actually is increasing or decreasing. Junxiong, yes. Increasing, yes. So our gradient is increasing gradient, right? Increasing gradient. So just now we got mentioned gradient is represent what? Gradient represent velocity. Am I right? Gradient represent the velocity. So when you are increasing the gradient, meaning that you're increasing the velocity, so we can say that it is accelerate. Object accelerate. Okay, increasing gradient, so object accelerate. Okay, another case at here. I don't need to draw a complete triangle. I can just draw like this. Like this. Draw the line. Okay, the line will be showing my triangle like this. And like this. Okay, I don't need to draw a complete one. Okay, so can you see at the behind part? Okay, as time goes. So at here, your gradient actually is increase or decrease. Decrease, yes, correct. Both of you correct. So this one is decreasing gradient, decreasing gradient. So as I told you, gradient represent decreasing here, we write, okay. Gradient represent your velocity. That means right now for this graph, decreasing gradient, decreasing velocity. So the motion is deceleration. Okay, write it down, deceleration. Okay, is it okay? Can we proceed to the page number 4? Okay, so we look at this. Okay, now, because this is a displacement, that means that it might be changing direction. It might change the direction, okay? So you look at here, just now starting at 10 meter. At the end, from time to time going, it come back to here. This one becomes 0 meter. What does it mean? Meanings that are moving backwards. Object moving backwards. In moving back to the original position, original position. Okay, but here, can you tell me that what is the gradient here? Zero gradient, constant gradient, increasing gradient, or decreasing gradient? Constant, am I right? So the gradient is constant, but here we found that if you do your mathematics, y2 minus y1 divided by x2 minus x1, you will get a negative gradient. Am I right? Negative. That means that your gradient is constant but negative. That means that what? Your velocity is negative velocity. Like boys and girls, do you know that velocity, you get a negative value? What does it mean? Okay, object moving to the, for example, object moving to the right, we said that velocity is 4 meter per second. Okay, when object moving in opposite direction, we will say that velocity is 4 meter per second, but not enough to represent. We should add a negative for it. So boys and girls, yes. Junseong, yes, correct. So when you have a negative, meaning that opposite direction, but it doesn't mean that it slow down, not slowing down, no, they are same speed, okay, but they are in opposite direction. So can you see that when you're finding the gradient for this graph, you will get a negative gradient. Gradient represent velocity, so it will be a negative velocity. Negative velocity meaning that opposite direction. So it moving backwards, moving backwards. So at here, what is the motion? We can say that the motion is constant velocity because you get constant gradient what? But here, okay, opposite direction. Or we say moving backwards towards to the origin, opposite direction. Okay, is that clear for this part? Until this time, t equals to 0, t equals to maybe 10 seconds. Okay, at here, back to origin, back to origins. Okay, is that clear for this part? Zheng, okay. Jiaxuan, at the bottom of our Zoom here, audio, video, participant, chat, and reaction. So you can press the reaction so we know that everybody is, yes, correct. Okay, dear, okay, so look at here. Can you try to think what happened to the gradient? And then what happened to the velocity? And then here, what is this? So you try to tell me first, the gradient. 0, increase, decrease, constant. Zunxiong, correct. Okay, let me draw like this, dear. This is my triangle. Then this is my triangle at the end. So, Jiaxuan, what do you think? At the end, at here, this one, the line and the gradient, yes, increasing. So this one, we write increasing, increasing gradient, the gradient is increasing. Okay, but you are also finding that this gradient is negative. Am I right? Negative gradient. Okay, so at here, increasing gradient, gradient represent velocity what? So we are accelerate. Object accelerate in the opposite direction. Yes, Zunxiong, correct. Okay, opposite direction. It's accelerate but in opposite directions. So it's also moving from 10 meters and then back to origin. Back to origin. Okay. The last one at here. Okay, again, think about the gradient. So I draw the gradient. Now the gradient is increase or decrease or constant or zero. Yes, correct. Jiaxuan, correct. Zhixiong, correct. Okay, so we write decreasing velocity, decreasing velocity, decreasing gradient first, gradient. Okay, I know the gradient is decreasing, so decreasing velocity. Okay, then it's in opposite v minus negative. Okay, the value will be negative gradient. So at here, decreasing velocity, that means that decelerate. Okay, it's also moving in opposite direction. Moving backwards, okay? Until the end, it back to origin. Okay, is that clear? Junxiong, okay? Jiaxuan, okay? Okay, dear, look at here. Distance and displacement is different. Distance is I don't care how you move. I just need to know your total path. So we won't for distance, we won't go back one. I just continue adding up your direction. Okay, so you look at when we throw something upward, speed will increase or decrease. When we throw something upward, it will against gravity. Am I right? So the velocity at here, it should be decreased. Am I right? It should be decreased. When it decrease until the maximum height, your velocity or your speed will should be zero. Am I right? From here, it will fall down. So falling down, gravity pulling. Velocity should be increased. How we plot the graph of this motion in the distance time graph? So can you see that for this part, velocity should be decreased. Velocity decrease, what does it mean? Your gradient should be decreased. Right? So if we draw at here, the triangle at here, you will find that this is actually showing us a lower gradient. Okay, until here, do you able to get my idea why this part is looks like this? Why the graph line is like this? Zhensheng, okay, this part. Jiaxuan, is it okay? Gradient decrease. Okay, so can you see that for this one, this part, for the distance and for the displacement are the same. These two are the same, nothing changed. But the difference is when they change direction. Displacement, we have to consider direction, but distance, no need. I just want to continue the total path. Okay, when velocity increases, so second part for here, velocity should be increased. So this one, gradient should be increased also. Gradient should be increased. So if I draw the gradient, so this one and here. Okay. So can you see that my gradient at here, this part? My gradient becomes a higher gradient. So this part is starting. Okay, this is ending. So we found out that gradient increase. So the graph should be acting in this way. Do you able to get my point for this distance time graph? Is it okay until here? Zhuxiong, okay, Jiaxuan, okay, good job. Okay, then the difference is here already, dear. Displacement. The displacement, because they change direction, so you need to, from here, then you're going back to original position. Here 0. So here is 0. We're starting from here going up until the certain height here. Displacement here, maximum height. So at here, this one actually is maximum height. You see, here is maximum height. Then it will drop and then go back to original position. So our graph should be going back, but it's how we curve it. How we curve. Curve like this, or like this, or actually it's the straight line. That is the thing we have to think, okay? So for this part, we understand that velocity increase, gradient should be increased. Okay, so how the graph is looks like, why it looks like this is, okay, let me using this. This is the gradient and here is the gradient. So can you see that this gradient is increases? At here, at the end, at here, the gradient is increases. So velocity is increased, but it is moving backwards. It moving, go back towards to the original position, towards to the origin. So until here, do you able to differentiate between distance and displacement? Their graph will be different, no dear. Their graph will be different. Okay, especially their graph after the changing direction, they will be showing different here. So Jiaxuan, is it okay? Okay, so we goes to your page number 5. Okay, one more part at here, then we will go to the partial questions. Okay, displacement time graph. So at start, it's already standing at certain position. This is 0, okay? It's already standing at some way, okay? Initial displacement from origin. Then number 2 at here, can you see that this is a constant gradient? Okay, because this is a straight line, constant gradient. So this part should be constant velocity. Constant velocity. Okay, moving with constant velocity. After that, here we draw a line to show the gradient, and here show the gradient. So we found out that the gradient increase. So that means that this one speed increase, or we say accelerating. Okay, number 3, object is accelerating at the section 3. Okay, section 4 is horizontal. Any gradient? No gradient. No gradient, no velocity. So that means number 4, object is at rest. Okay, until here, is that clear? Until here, is that clear? Okay, Jiaxuan, okay? Yes, okay. Here, there, look at this. Number 5 at here. Okay, this one is important already. Displacement. You see, it start to move from some way. Okay, here this is 0, our starting 0 meter. Okay, it's starting from maybe 10 meter. Then it start to move until section 2, section 3, section 3 at here. Okay, somewhere here. Okay, it stop at here and then rest for a short while. Then after that, can you see that for here? If let's say this one is already comes to 100 meter lah. Okay, let's say here is 100 meter. This is 10 meter. Right now, if from here is going back, can you see that? Going back. So your 100 meter will decrease, decrease, decrease. So what does it mean? At here, it will start from section 5 at here. It will moving backwards. It will moving backwards. So this one is section number 5. Okay, section number 5 is moving backwards. Okay, so this one is section, here is section 1. Okay, then this one is 2, 3. Okay, until here it rests for a short while for number 4. Okay, from 5 is trying to moving backwards. Okay, here if you're trying to find the gradient, it's a straight line. So how it move? Constant velocity, because constant gradient. But if you find the gradient, you get a negative value, so that we understand this is negative velocity, meaning that opposite direction. So it's move backwards. Here, opposite direction. It start to moving in opposite direction, moving backwards. Okay, until section number 6 at here, it go back to original position. Here is 0, meaning that it go back to, oh sorry, this is not 6. Okay, 6 is it go 5 until here. Until here. Okay, then this one is number 6. Back to 0 meter. Okay, how about the 7? Okay, 7 at here, it will be negative, meaning that it still continue moving backwards. It still continue moving backwards. Okay, this is section number 7. Continue moving backwards. Okay, so at here, same thing is moving in a constant speed. Okay, so this graph roughly to give you some idea how it moving backwards and then continue moving backwards. So from the starting, okay, our starting points, this is considered 0 point is our starting point. At start, they're starting from a certain value, this certain distance, certain displacement from the origin. Okay, so it start to move forward until number 5. It start to moving backward until point number 6 is come back to 0 meter, and then 7 is it continue moving backwards. Okay, until here, is that clear? Okay, this 3, 5, 6, 7 is a straight line, so it should be a constant velocity, but moving in opposite direction only. Okay, write it down. Then if clear, then we were trying to do past year question. Okay, test our understanding by using past year questions. So we go to the question number 1 at here. Okay, this is a displacement time graph. So you need to interpret how is velocity. Okay, which graph show the variations with time of the velocity v of the car. Okay, so you have to think. I got you for the first one. Velocity. So at here you write gradient of displacement time graph is actually velocity. So you are going to find velocity. So you have to know the gradient, right? Gradient. So from here to here, draw a triangle for us to find the gradient. So for the first part, what is your gradient? What is your gradient for the first section? Okay, the gradient represent velocity. So your velocity should be 1. So you're using 2 divided by 2 is 1. So can you see that 1 here, okay. 2 here is wrong. Then this one, -1 is wrong. Then this one, 1, okay. So our answer should be A or D only. Okay, A or D only. So at here, what is your gradient for the second section? 0. Yes. Second part is 0 because if you're using 2 minus 2 divided by 2, here is actually no gradient. 0. So at here, second section at here, it should be velocity should be 0. So this one correct. This one also correct. Okay, these two are correct. Okay, then we look at this. From the 4 second to 6 second, what is your velocity? What is your gradient? How your gradient? Jiaxuan, do you able to follow? -2. Okay, -2 meter per second. Negative meaning that you are moving in opposite direction. Okay, so -2, this one is correct. Here is wrong. So your answer should be A. Okay, is that clear? Okay. Then we go to the next page, question number 2. Okay. What is the speed while it is moving? Okay, can you try? A car at rest in the traffic, then move forward in a straight line, then come to rest again. So the graph showing the displacement time graph. What is the speed when it is moving? Jiaxuan correct. Okay, speed. Teacher, this is displacement time graph. It should be a velocity what, dear? As long as they are still moving forward, velocity and speed are the same. The velocity and speed only different is when they change direction. Then the graph will be different. So as long as they still continue moving forward, you can say that this is speed, you can say that this is velocity. They will be the same. Okay, these two will be the same. So how are we going to find? Okay, the speed is the gradient. So we're using this part to find it out. Okay, so you should be 70 minus 30 divided by the time is 100 minus 50. So at here, your answer should be 0.8 meter per second. Okay, I will encourage 0.8 is actually one significant figure. Our answer, we need two significant, 2 to 3 lah. Okay, so I should add 0.80, see? Meter per second. So answer is B. Is that clear? Yes or no, dear? Yes. Okay. Okay, Junxiong. Okay, to a shop. Okay, taking 10 minutes. The student then spend 5 minutes in the shop. Then before cycling home downhill at twice the initial speed. Which graph can represent? Okay, dear, you try. Jiashen, yes, correct. Very good. We're waiting for Junxiong. Junxiong, try. Junxiong, tell me your answer. Okay, yes, dear. D. A and B confirm wrong. A and B it moving backwards. This part got moving backwards. But for distance, they will never moving backward. Unless here you writing this is displacement. Okay, if you write distance, it will always going up, 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 up because it's total path. Okay, so at here they said that 10 minutes. Okay. So at here this part is correct. This one only travel for 5 minutes, so this is wrong. Okay. So D, answer is D. Okay, we go to your next page, page number 7. Question number 4. Okay, can you try? At start constant speed. Then after that, decelerate. At the end, stop. 3 section. Jiaxuan, correct. Good job. So answer, because Junxiong internet problem, okay, it's okay here. Answer should be B. So at start at here, this one is a straight line. So this is section 1. Okay, then after that, it curve like this. So it curve like this is actually slowing down. Okay, so this is section 2. Okay, the last step section is here, horizontal. So this is section 3. At the end, it stop. So second part and the first part. Answer should be B. Yes, correct, Junxiong. So then we go to the next number 5. Can you read it and then you tell me your answer? Oh, this one should be easy. Similar with just now. Jiaxuan, no. Jiaxuan, no. Try again. Junxiong, correct. Okay, dear, always be careful. This is called distance. So Jiaxuan, distance never got going back. So this part is wrong. Here, going back, no. So the only answer is we need to consider B or D. Jiaxuan, correct. Answer is D. Okay, answer is D. Should be fine, right? Okay. Okay, goes to your next page. Question number 6. Okay, read it and then you try and then you tell me your answer. Try and then tell me your answer. Don't know. Tikam, tikam. Try to guess. I give you some hints. You look at my screen. I show you. You look at my screen. So this one, it will move forward like this, a pulse, moving along. So 0 second, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, 7 second, X second. So what's going on to your point P? Then after that, move, 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 move. How is motion? Until here again, what's going on? Then here. No. Jiaxuan, no. Zhixiong, try. So you look at here, at start is not moving. Yes, this one is for sure. Okay. Still confusing. Okay, dear, you look at me. So at the first part at here, when pulse moving, actually the P is not moving. So for the first part, all is not moving. No distance travel for point P. This one okay? But then after that, when suddenly the pulse coming at here, this point will go up. Okay, when the pulse coming, this pulse will go up. So it will go up. This one confirm wrong. This one confirm wrong. Only B and D correct. So until here, is that clear? The pulse, it will follow the shape coming and then go up. Until here, okay? This pulse will go up at here until here. Okay, Zhisheng, okay? Jiaxuan, okay. Then until here already, okay, until here, standing at the upper part at here, then I continue move my pulse. So you imagine the pulse is, the P point is actually at the upper part. So how? Wait. It will continue move. So the pulse will be stay at the upper position. Am I right? The pulse, it will be stay at the upper position, horizontal. That means that it will stay along here until the pulse finish, until the pulse coming until here. Do you agree? So your answer should be donkey. It stay at here and then it continue travel for a short distance that at high position. After that, when comes to here, what's going on with the pulse? The pulse will going down. It will going down. So from the pulse at here, it going down. Now it's because the motion is going to the P point. Motion is something like in this direction. But when we plotting the graph, it's in the right directions when the time is increases. So as start is 0, not moving, but once the pulse coming, it will move up and then stay at the upper part at here, then the pulse continue moving, so it will still continue staying at the upper part at here until here it will going down. So it should going down, then going down again, going up at here and then stay again. So your answer should be donkey. This one need your imaginations and how the pulse moving and how's the particle P, this point, is actually move. At start is 0 until the pulse coming, it go up. Go up, then it will stay at there for a short distance. So actually it will travel at the certain position, okay, certain distance. Then after that, it going down. So answer is donkey. Do you able to accept this answer? Yes. Jiaxuan, okay? Okay, so we goes to the next question. Okay, the graph showing a variations with time t of the displacement s of an object. Which graph represent the variations with time t of the acceleration a of the object? They want you trying to convert from the displacement time graph to acceleration. So first, from here, we cannot directly go to the acceleration, cannot. You have to think about velocity first. You have to think about velocity first, okay? So velocity at here is what? What is this motion? Can you tell me what is this motion for this part? Constant velocity. Here, constant velocity. Am I right? Constant velocity. When constant velocity is equals to how many your acceleration? What is your acceleration when constant velocity? Zero. Yes, zero acceleration. No accelerate. It's constant velocity, no accelerate. So at here, no accelerations. That means that this part, from here to here, your A should be 0. Okay, we divided into few parts. Section 1, 2, 3, and 4. 4 section, okay? So at here, 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. Here also 1, 2, 3, and 4. Something like this. Okay, as long as you're showing some reading, the answer is wrong. What is your answer? Answer for this question should be D. This part A is 0. A is 0 for the first section at here. Okay, then A, B, C, D all are wrong answer because they got value for the acceleration. But when they're moving with constant speed, there is no acceleration. Answer is donkey. Second part there. Okay, for this part, so what is the motion? Can you tell me what is the velocity? Constant, 0, increasing, decreasing for the second part. What is your what is your velocity? Constant velocity in opposite direction, yes. It's still constant velocity, but in opposite direction, moving backward. So constant velocity again, this one I write down, constant velocity. If constant velocity again one more time, acceleration is 0. So your second section at here, it should be 0 again. But they will have a sudden change at here. The direction suddenly change. That's why your acceleration, it will have a suddenly change. Okay, it will have a suddenly change. The change in velocity at here, the value at here that we get is negative. So your acceleration here will have a suddenly change of velocity, of acceleration. But along it travel with constant velocity, this one acceleration should be 0. Answer is donkey. Is it okay? You interpret the graph. You cannot straight from displacement time graph to acceleration, cannot. So with 2D velocity, from velocity, we think about that. Okay, good job. Okay, there we go to your next page, page number 9. A toy train moves along a straight sections of track. Figure 1.1 shows the variations with time t of the distance d moved by the train. Okay. Describe qualitatively the motions of the train between the time 0 to 1 second. What is a motion? 0 to 1 second. You already learned how to interpret the graph. So can you tell me 0 to 1 second, what is the motion? Zhuxiong, yes. Now I'm waiting for Jiaxuan. Jiaxuan, what is the motion? Accelerate. Jiaxuan, so you draw the gradient. The gradient is increase or decrease? Becomes steeper or less steep? Okay, decreasing gradient. So at here, your answer can be said that decreasing velocity, or we also can say that decelerate. Okay, or you say velocity decrease. Okay, From the graph, it's showing you gradient decreases. So actually, it should be velocity decreases. Okay, can you calculate determine the speed? Okay, here speed of the train at t equals to 2 seconds here. What is the speed? 2 seconds. What is the speed? Jiaxuan, yes. Junxiang? Speed is we're finding the gradient. Okay, we can find the gradient. So finding gradient, I want you to draw a triangle. Zhuxiong, no, not correct. Okay, gradient is y2 minus y1 divided by x2 minus x1. So we can draw a triangle for the straight line path. Okay, I can draw using any point, as long as is within the straight line at here. Because any point that I use and I draw the triangle, I will get the same answer. Straight line showing constant gradient. The gradient will be constant. So at here, this point that I use is 3, then 0.56. So here is 1.5. 1.5, then this is 0 minus 0.20 divided by, our answer should be 0.24 meter per second. This is speed. For this, they test on you. Do you know that how to find the speed from the graph? Okay, so this answer. Okay, okay, so we can proceed here. Okay, the straight sections of track in B is part of the loop of track shown in the figure here 1.2. The train complete exactly one lap of the loop. State and explain the average velocity of the train over the one complete lap. What is your average velocity? What is your average velocity? One complete. So for example, I start from here, I move, then I continue moving, then I continue moving, then I continue moving, then I continue moving. Okay, tell me, what is your average velocity? Zhenxiong, yes. You get the point. Yes, correct. Jiaxuan, what is your average velocity? Average velocity is the total displacement divided by time. Jiaxuan, tell me. What is your displacement? First question, what is your displacement? Jiaxuan, no. What is your displacement? If you complete, what is your starting? What is your ending? What is your displacement? No. Dear, starting, then you go back to original position, ending. What is your displacement? When you go back to original position, what is your displacement? 0, yes. So when you complete one lap, actually go back to original position. So your displacement actually is 0. 0 divided by the time, actually still 0. Your average velocity should be 0. Why? Because displacement is 0. Okay, 1 mark here. Is it okay? Okay, both of you, okay, good job. There we comes to here. Okay, a car of mass 1,500 kg travels along a straight horizontal route. The variations with time t of the displacement x of the car is shown in the figure 3.1. Use the figure 3.1 to describe the qualitatively the velocity of the car during the first 6 seconds. Okay, this is 6 seconds. At here, give your reason for your answer why you say that the motion is like the velocity is like that. Okay, you look at here 3 marks. So that means that they want you to write 3 points, which means that most probably here actually there's 3 sections. Okay, 3 mark for 3 section. So what is this velocity? What is this part velocity? And what is this velocity? So you need to give me 3 sections. What happened to the velocity and why? Can you write down your answer? Three section, write down your answer and then tell me why. You need to give reason for your answer. Any of you can answer me? I'm waiting for quite a long time. 3 section. First section, tell me, what is your velocity? Constant, decreasing, and constant. Yes, correct. So, Jiaxuan, correct. Then you have to write the reason. Okay, for the first part, initial is, Junxiong got answer already. Oh, you typing, that's why take long time. From 0 second to 2 second, the car moving with a constant velocity as the gradient is constant. Good. 2 second to 4 second, the car moving with a decreasing velocity because the gradient is decreasing. Yes. Then 4 to 6, constant velocity. Yes. Because gradient is constant. Yes. So dear, I no need to write for you. Okay. So Jiaxuan also correct. Okay. You talk about gradient. So we can say that initial velocity is constant because gradient is constant. This part. Okay. I'm using my highlighter. So starting is this part. Okay, roughly somewhere here. Then after that, second section is somewhere like this, is curve, okay? Then the third section is somewhere here. It's a straight line. So your answer is correct. Both of you are correct. So initial velocity is constant because gradient is constant. Then velocity decreases. Okay, the second section or middle section is the decreasing velocity because the gradient decrease. Okay, the last section is constant velocity again because gradient is constant. Okay, any questions? Should be okay. Two of you answer correctly. Okay, can you calculate the average velocity during the time interval 0 to 1.5? Can you calculate the average velocity? How? And then tell me, calculate. Let me have a look, Jiaxuan. No, dear. Zhesheng correct. Jiaxuan, no. Your answer should be 30. 1.5 is somewhere here. 1, 2, 3, 4, 5. Okay, 1.5. So if we're drawing up somewhere here. Okay. So this one is 40. So 1, 2, 3, 4, 5. This is 50. Okay, so this is half of it. So this one is 45. This part actually is 45. You can't. Let me label. This point is actually 1.5, then 45. So Jiaxuan, this one should be the 45 divided by 1.5. So your answer should be 30 meter per second. 28 cannot. They don't accept. Okay. So this one is for the next part, second part. Okay. The velocity. Okay, dear. Here until here, I want to emphasize another thing at here. Last section just now. It's a constant. Okay, it's constant, but we found out that this part and this part, the first part actually is steeper. The last section is also a straight line, but it's less steep. Okay, so at here, this one, maybe you can emphasize. This is a constant velocity, yes, but it's lower constant velocity than your first section. Okay, it will be then at start or first section. Okay, it will be lower constant velocity than starting. Okay, smaller constant gradient. Okay, is that clear? Okay, Jiaxuan, okay? Okay, dear, we goes to the worksheet number 6. Is it okay for you? Worksheet number 6. Come here, velocity. Just now what we learned is about displacement time graph. Okay, now we learn about velocity. Okay, for velocity at here, if you're finding the gradient, okay, so we look at here, for example, this one. If we find the gradient, this one, gradient, we find the triangle. This gradient will be the V divided by T. Am I right? V divided by T. So this one gradient is V divided by T actually is our acceleration. When you're finding the gradient for velocity time graph, it will show you acceleration. If you find the area under the graph, for example, like this is the V, this is the T. So this is the time. Okay, if you're finding here, okay, this is area under the graph. Area under graph is 1 over 2 V times T. Okay, speed times time. Speed times what you will get? Speed times. So you will get a distance, or we say displacement. Is that clear? V velocity is ms -1 unit. Time is in second. Second -1 times second. Actually, this one can be cancelled. Your only unit is m. M is the unit for distance, or we say displacement. So when you are calculating area under the graph, you are calculating the distance, or we say displacement. As long as they didn't change direction, they will be the same. Okay, until here, is that clear? Okay, good job. Dear, we look at here, first graph at here. Velocity. What is your velocity for your graph number 1? Any velocity value? No, right? Because it's there at 0 here. Am I right? Here, 0. So this one is 0. No velocity. Is there any gradient from the graph? No. No velocity, no gradient, no acceleration. What does it mean? Object at rest. Object actually at rest. Get it? No speed, no velocity, of course not moving. Okay, next, second one. Okay, this one is actually I combine in forward direction and opposite direction. Okay, I didn't split it out. I show you. Actually, these two, their motion are the same. Same motion. Okay, for example, this one is 10 meter per second. So this one. Then this one is negative 10 meter per second. Negative 10. Negative 10. Negative against. Just now we already learned velocity negative meaning that opposite direction. So this one is move forward, this one is move backwards in opposite direction. But their motion is the same, okay? So here, velocity. Horizontal line showing you velocity 0, constant, increase, or decrease. What do you think? How you interpret the graph? Constant. Junxiong said constant. Yes. So this one should be constant velocity, right? Okay. What is the gradient here, dear? What is the gradient? 0, constant gradient, or increasing, decreasing? 0. Okay. 0 gradient. When 0 gradient, what does it? 0 acceleration. Am I right? So your acceleration is 0. So what is the motion for this? Constant velocity. Okay, constant velocity, no acceleration. That's why your A is 0. Okay, Jiashen, is it okay? Both lines are the same motion. Just the green line is in opposite direction. That's all. Okay, so we look at this. Third graph at here. Okay, what happened to the velocity? You look at the graph. What happened to the velocity? What happened to the velocity? Increasing. Yes. So at here, increasing uniformly. Okay, velocity is increasing uniformly, right? Okay, so at here, the gradient is constant gradient. Am I right? Constant gradient at here. Gradient meaning that your acceleration, meaning that constant acceleration. Constant gradient meaning that constant acceleration. Okay, so velocity increasing represent accelerate. Uniformly, that means constant. Okay, so what does it mean? Okay, it can be like this. Starting 0 meter per second. After that becomes 2 meter per second. After that become 4 meter per second. After that become 6 meter per second. So can you see that every time ms negative with plus 2, okay? Increase plus 2, plus 2, plus 2. We are accelerate, speeding up. From 0, speed up to 2, speed up to 4, speed up to 6. Every time I speed up, every 1 second I speed up, I'm constantly increasing. So plus 2, plus 2, plus 2. This is called constant acceleration. Is that clear? Junxiong okay? Jiaxuan okay? Okay. So green color is the same, constant acceleration, just in opposite direction. So dear, you need to be very clear at here. This one is negative velocity, showing opposite direction. You don't tell me that the velocity decrease. Velocity doesn't decrease. Here is 0. I start at here is 0. So it are increasing to maybe here negative, maybe here is negative 8. So from 0 to 8 actually is increasing. Velocity is increasing. The negative is just showing you opposite direction only. So you don't, common mistake is student will think that here is negative 8 becomes smaller. From 0 to negative 8 becomes smaller. But no, the negative is just showing you direction. Actually, the magnitude is from 0 to 8. You are increasing the speed. Okay? So we look at the last graph at here for the page number 1. What happened to your velocity? Tell me what happened to your velocity. Decreasing. Yes. Okay, velocity decreasing. Okay, here. Velocity decreasing means that decelerate. Then here, how it decelerate is depends on your gradient. Okay, your gradient is a constant gradient, increasing gradient or decreasing gradient. Constant. So we hear constant deceleration. Why? Because this part is gradient. Okay, constant gradient. Constant gradient. Okay, then negative gradient, so showing that as deceleration. Negative gradient. Okay, negative meaning that deceleration. Okay, here constant deceleration. Deceleration meanings what? Okay, for example, here we starting from 6 meter per second, become 4 meter per second, become 2 meter per second, become 0 meter per second. It is slowing down. Am I right? The speed is changing. So every time it's negative 2, negative 2, negative 2. It's a constantly decreasing the speed. Is that clear? Is it okay? Blue color and green color is the same motion. Just green color is in moving in opposite direction. That's all. Okay? So they are slow down for this graph. Session okay? So we're going to the page number 2. Is it okay? Goes to page number 2. Okay, here. What happened to your velocity? So this one I already draw the line to show you what happened to the velocity. From the graph, from 0 here going up. So velocity is increasing. So we write velocity increasing. But this is not a straight line. So this one is non-uniform, uniformly. Non-uniformly increasing the velocity. Bottom part, green color also increasing speed there. This is 0. This is maybe 8. Okay. Bottom part, green color line is also increasing velocity. Okay, but just in opposite direction only. Gradient represent your acceleration. So can you tell me your gradient is increasing, decreasing, 0 or constant? Increasing. So increasing gradient at here, and then I know that gradient is acceleration, so it will be increasing acceleration. Okay, so at here, increasing acceleration means that we accelerate, we speed up. Am I right? So at here, 0 ms negative 1. So it might be going to 1 ms negative 1, then goes to 3 ms negative 1, goes to 6 ms negative 1. So it speed up. Yes, every 1 second it speed up. Then how it speed up? You see this one plus 1, this one plus 2, this one plus 3. It's not a constant, it's not constantly increasing the speed. Okay? It's increasing the acceleration. This is the meaning, increasing acceleration. Plus 1, plus 2, plus 3. Every 1 second, they increase the rate. Okay, is that clear? Good job. Oh, very good. Okay, dear, here. Tell me for the second graph, velocity is 0, constant, increasing, decreasing. What do you think? Velocity, velocity. I'm not talking about the gradient. I'm not talking about acceleration. I'm talking about velocity, dear. Velocity. Velocity still increase, right? From 0 to a certain value. No matter like this or like this. Actually, it's increasing velocity. So at here, increasing velocity. Again, it's not a straight line. So this is non-uniformly. Okay, deal. This one is still increasing velocity, meaning that it's still acceleration. Okay, the motion is still acceleration. But how it accelerate? Increasing acceleration, constant acceleration, or decreasing acceleration? What do you think? Decreasing, yes, decreasing. Okay, so the decreasing is because we understand the decreasing gradient. Okay, decreasing gradient. So here is decreasing. Then because the speed still increasing, so it's decreasing acceleration. What does it mean? Meaning that decreasing acceleration. Okay. We still accelerate from 0. So it might be goes to 5. It might be goes to 9. It might be goes to 12. Okay, so at here, it still speed up. Can you see that from 0 to 5 to 9 to 12? But here, they're increasing. This one is plus 5. This one is plus 4. This one is plus 3. They are decreasing acceleration. But overall, it still accelerate. But not that fast, they accelerate only. Still accelerate. Is that clear? It still accelerate, but the rate they decrease, not that fast only. Okay, the next one, the graph at here. Can you tell me what happened to the velocity? Velocity decreasing. Okay, velocity decrease. Deceleration, slow down because velocity decrease. Okay, so at here, the front one, how you describe the deceleration? Constant, increasing, decreasing. So what is your answer? Increasing, very good. Increasing deceleration. Okay, decelerate meaning that it slow down. So example, 10 meter per second, it slow down become 9 meter per second. Then it becomes 7 meter per second. It becomes 4 meter per second. Okay, so at here, this one is minus 1, minus 2, minus 3. Okay, it slow down and then increasing the slowdown. Increasing the rate of slowing down. Deceleration meaning that slow down. Is that clear? Jiaxuan, Junxiong. Okay, good job. Last one. Then we can practice already. So at here, what happened to your velocity? Decreasing, yes, thank you. Decreasing velocity. So again, this case is deceleration. How you decelerate? How it decelerate? How's the gradient showing you? The gradient become less steep. Am I right? Yes, correct. Decreasing deceleration. Okay, what does it mean? Starting 50 meter per second, then you will become 10 meter per second, then we will become 6 meter per second, it will become 3 meter per second. Okay, so at here, this one is minus 5, minus 4, minus 3. Slow down, decreasing deceleration. Actually, for this one, I just want you to know how to interpret. How to interpret. Okay. Is that okay? Can we go to page number 3? Okay, let's go, dear. Look at here. When we throw something upward, as I told you, velocity should be decreased because against gravity. Against gravity. Okay, the velocity dropping, the object dropping, so velocity should be increased because gravity pulling, and we will accelerate what? We know that object drop, it will be accelerate at 9.81 meter per second, okay? So at here, when the speed decreases, going to the maximum height, speed decreases. Can you see that? Speed decreases, velocity decreases. Until this point, at your maximum height at here, maximum height, your velocity is 0. Is that clear? So at this point, velocity is 0. I know this point actually is maximum height. Then object will falling down, it will change direction, am I right? So when it change direction, you should draw at the negative v to showing this is opposite direction already. And then speed will increase. Here is 0. This part is 0. 0 to some value here. Actually, for example, this one is 8 lah. Okay, whatever. Or whatever, 100. Okay. So at here, 0 to 100, although it's negative 100, but negative showing direction only. So you are speeding up. So this part is actually speed increase. Here is actually speed decrease. Is that clear? How we plotting this velocity time graph? Is that clear? Okay, Jia Xuan, okay, Jun Xiong, Okay, so we goes to another case. I standing at certain height, then I throw it up. Same thing. At the first section is the same thing, velocity decrease. So it's this part, velocity decrease. So this is the velocity decrease, this part. Okay. Then after that, we reach to the maximum height. This is maximum height. When the velocity is 0, that is maximum height. Maximum height. Velocity is 0. Okay, after that, it's falling down. Velocity should be increased. So these sections, it should be here, this part. Okay, until here is exactly the same as just now. But because when I start standing, I'm standing at certain height. Actually, it still continue falling down from my current positions. That means that it will continue moving in backwards directions, opposite to initial motion. Okay, so at here, from here, it will continue moving downwards. This part actually is the distance from here to here. This is the distance. How I know area under the graph is distant? Just now we got mentioned gradient for the velocity time graph is find acceleration. Area under the graph for velocity time graph is actually the distance. Is that clear? Okay, dear. Jia Xuan, okay? Okay. So next, we drop something, okay? So drop a ball. So let's say at here at rest. So at rest, velocity is 0. At start here, u is equals to 0. Then we drop it. After we drop it, it touched to the ground. Just before it touching, just before it hit on the ground, actually that is a maximum speed before it touching. So we will go and then hit at the maximum speed at here. Then suddenly it changed to opposite direction. Is because this part is actually touching and then hit and rebound. So at start at here, this section is ball falling. Ball falling, velocity increase. This one is velocity increase because falling. Falling, so velocity increase. Then they touch to the ground and then they hit and rebound. They suddenly have a change in directions. So at here, this is our speed. It changed direction and moving upward. It will against the gravity. If you against the gravity, your velocity will decrease. So at here, this one v from a certain value at here decrease to 0. So this is the part that the ball rising, going up. Okay, until here velocity is 0, actually is because it's reaching to the maximum height. For this graph, do you able to interpret with the situation? Interpret the graph. Where is the point that you hit the ground? Where is the point that you reach the maximum height? Okay, Junxiong, okay. How about the Jiaxuan? Okay, here, area under velocity time graph. Okay, for this part, if this one they want you to find distance, actually it's very easy. You just goes to this you just finding the area distance traveled by this part, area A. Okay, this one is object moving forward because here is positive velocity, is positive, so it's moving forward. Okay, for this section A is moving forward. After that, it rests for a short while. Section B is at negative. Here is negative velocity. That means that opposite direction. So at here, it will move backward for B. B area is smaller. So this one area A, so it moving backward B. Okay, if I want to know about the distance, what should I do? I don't care about how you turn backwards. I just want to know the total distance. So you just calculate the A plus the B, settle. That is my distance. So area A plus area B, that is my distance. But how about displacement? Displacement is different story. Here is starting. Here is starting. Here is your ending. Okay, I want to know starting to ending. This is my displacement. This is my displacement, starting, ending. Actually, the object is like this, moving and then go backward. I didn't draw on the same point of on the line, cannot see. That's why I draw at the bottom part at here. So supposedly it's going here and then going to the right, then you turn backwards somewhere here. Okay, displacement is starting, ending, that is the displacement. Okay, so how are we going to find displacement? We should find the total A. For example, total A is 10 meter. Total B at here is maybe like 3 meter. Okay, so what is your displacement? You're using 10 meter minus 3 meter, then you know that 7 meter is your displacement. So at here, if the question asking you to find displacement, you should using minus. If they're asking you about the distance, you should plus it together. I don't care direction, just plus it together. Okay, until here, is that clear there? Okay, Jiaxuan? Okay, so for the exercise part, so next week we continue it. Okay, next week we continue to practice about this velocity time graph. Okay, any question right now? If no question, then